Good afternoon, good evening, everyone. This is Umar Mukra again. I'm one of the team members at OpenEBS, and glad to be here. This is our second online Hangout. Incidentally, we released 0.3 version of OpenEBS today. So let me talk about a little bit of OpenEBS overview to begin with, and then we will delve into project updates, mainly what we did with OpenEBS 0.3. And then my colleague Amit will be doing a detailed demo of OpenEBS 0.3 release, where he will show the complete Kubernetes hyper-converged integration of OpenEBS with the Jupyter data science tool as an application that requires stateful persistent storage, right? So with that, we will we'll start with OpenEBS. So to begin with, let me talk about why OpenEBS, and then we'll talk about what is OpenEBS, right? So as we all know, persistent storage is still a problem that is to be resolved in the stateful applications area for containers, right? Kubernetes has done a lot of work in resolving the architecture that is needed for connecting the containers to the stateful applications, to the underlying persistent storage. But the storage itself needs to be evolved when we have to say that that is the right storage for containers. And that's one reason. The other reason why OpenEBS has come into existence is there's really no open source technology today to deploy an Amazon EBS-like storage on-premise or in cloud. Our goal here can someone please put your microphone on mute? Thank you. The other reason why OpenEBS came into existence, as I said, was to have one open source technology that helps you deploy an EBS-like storage on-premise or on another cloud. All said and done, Ceph is another probable storage that's close to be called as an open source storage option. We still believe that there is a gap to be filled to have open source block storage that really scales and performs well. So these are some of the goals because of which OpenEBS has come into existence. So in brief, what is OpenEBS? It is a containerized storage for containers. We are actually going to build storage volumes within containers, or the storage controller itself is going to be split into multiple containers to host the volumes. And typically, you will see in a containerized environment, the applications are containerized, and the application pod is going to consume the persistent storage, typically a legacy storage, using an iSCSI or some other ways of connections. But with OpenEBS, we are not going to use that model. With OpenEBS, we are going to containerize the volumes and then move them towards an application pod. Here in this scenario, the application pod will consist of application containers as well as the storage volume containers. And that's one way of resolving the persistence issue by moving volumes closer to the application. And that's just the connectivity part of it. And if you're planning to deploy a real persistent storage, it's not just about connectivity. And this storage needs to be really highly available all the time. The space needs to be managed once you put volumes into production, the space dynamics come into the picture, and then the latency, quality of service, so on and so forth. These are some of the characteristics of OpenEBS storage that will make sure that the persistent storage is always available and it is always performing according to the configured policies. So that's about what is OpenEBS, why we start building it, and how we actually built it. The current version is 0.3, and there's a lot to go. But let me just talk about how we are building the storage containerization piece. So we're using Docker underneath. Every volume, whenever you provision, we Dockerize the storage software for that volume. We call it as Jiva. Jiva is the Docker image using which volumes are built. And for orchestration, currently we are deeply integrated with Kubernetes. That's what this release 0.3 is all about. We have hyper-converged mode of deployment possible today with the 0.3. And Kubernetes obviously solves the problem of connecting a volume to a container pod. But there is more to storage operations apart from just the connections, right? All those deep storage operations are built into a control plane called OpenEBS Maya. So this control plane component, which is a Kubernetes service, it's going to handle the capacity management, latency monitoring, deep analytics, and it also exposes EBS-like APIs and all the other data protection related management tasks. And then we have the actual storage itself, what we call the data plane. This data plane or OpenEBS itself contains the containerized volumes, and it exposes a thin and scalable block storage image within those containers. And what you can expect out of OpenEBS data plane is the enterprise high availability capabilities, intelligent QoS, and then we are also going to introduce very smart tiering for a higher performance or to meet the expected latency levels from the underlying volumes. This is going to make use of some of the advanced technologies in hardware, either 3DX point from Intel or the regular NVMe flash disks for tiering from hot data into cold data areas. So this is an overview of how OpenEBS is built. Some of the components like tiering and QoS modules are still not there, and they'll be coming in future versions. Today, what we have with 0.3 is a completely usable OpenEBS storage that is integrated with Kubernetes with hyper-converged mode of deployment. And so that's about why OpenEBS, what is OpenEBS, and how it's built. Now let's actually talk about what is OpenEBS if I'm a DevOps engineer or a developer, right? How do I view this? So let's take a typical OpenEBS DevOps workflow without OpenEBS, right? So if you're using the stateless application, everybody knows that Kubernetes has solved the management and of that application in a very nice manner. You put the configuration of the application into a config YAML file and run it through Kubernetes, and then the application is spawned and everything works well. The same is not true for a stateful application. For stateful application, the containers can be connected through the persistent volume and persistent volume claims architecture, but still we have issue with the underlying storage itself, where the storage can be coming from multiple tiers. They're all hardwired through plugins. And then you need to manage the availability of storage yourself or from the underlying platform. With OpenEBS, this is going to completely change whether it is stateless or stateful. As a developer, you just fill in the characteristics of the storage that you would need. For example, you would put in the capacity and latency requirements into a config YAML file of your application, and then associate that with the storage class of OpenEBS, and the rest of it will be taken care by the OpenEBS provisioner. So it is going to express that intent into a policy in OpenEBS engine, and then the storage volumes are provisioned automatically. It's not just provisioned, they're scheduled in a manner that fits the requirements of latency and capacity. And for the rest of the lifetime of the volumes, OpenEBS manages those volumes without any downtime. So that's the architecture we're going towards. In other words, DevOps operations with OpenEBS is going to be very much simplified. Storage is not going to be an issue anymore if you're using OpenEBS underneath. Rolling applications, the stateful applications into productions will be very, very similar to rolling applications which are stateless into production. Having said that, we are introducing a new component called Maya. Maya is supposed to be a control plane for storage. So obviously, you would have questions on, Kubernetes takes care of the orchestration of storage, then why Maya, right? As I said earlier, Kubernetes is taking care of initiation of provisioning and connecting the containers to the underlying persistent storage. But we are now talking about the persistent storage itself being available through OpenEBS. So you would need another orchestration control plane. In this case, it is Maya, which will take care of many of the orchestration features for storage volumes other than just provisioning and connecting them, right? So those will include monitoring of the volume data, or we can call them as deep storage analytics, and scheduling very intelligently. Sometimes the volume need to be migrated from one node to another node because you increase the amount of IO ops that you need, and the volume may need to be moved to another node, right? And it also includes smart space management. Most of the data that we all know, it's all thin provisioned. As the capacity gets filled into the volume, the space needs to be managed very smartly. You may have to move the volumes or migrate the volumes from one node to another node. All that will be taken care by Maya underneath. And of course, availability of the volume during upgrades or any other malfunctions. And then comes to the data storage, data protection operations, such as backup and snapshot recovery. All that will be made application aware using some integration with Maya and the application. And then comes to the latency guarantee in QoS. We are thinking of putting a lot of intelligence into the underlying data storage layer, where the latency of various layers inside the storage is monitored and adjusted appropriately so that the guarantee of the latency, the guarantee of the QoS is met. And then comes the scalability, right? The scalability requires always you start with one rack of storage, and then as your applications grow or the number of applications grow, you need to increase the backend storage into multiple racks and sometimes multiple regions. So this involves a lot of data movement and a lot of planning, which will be helped with Maya's capability. And then comes, who will catalog different policies for different applications, right? As a developer, I don't want to be burdened with knowing a lot of storage behavior for my applications. It would be nice to have a catalog of storage classes for various applications so that I can pick and do that. So that also will be a capability that will be provided Maya in the near future. So in other words, what Maya is, it will provide an answer to every other question in the container environment for persistent storage, other than just provisioning and connecting them to the applications. So that's a glimpse of what Maya will do now and in future. We just want to cover, because a lot of the next meetups, Hangouts, and immediate developments are all going to be around Maya. So with that, I will hand it over to Amit, and probably I can take some questions now, or I'll be available for questions later in the sessions. Are there any questions for me? All right, great. Let me just hand this over to Amit for a detailed demo of OpenEBS 0.3 release.
Hey, hi everyone. Okay, let me open this. All right. So we will go on a tour of OpenEBS alongside Kubernetes, which is, in other words, a hyperconverged solution. What we will see in this demo are two different persona. One is a cluster admin, and the other one is a developer, to be specific, a data scientist. We'll see how the cluster admin tries to use OpenEBS, rather tries to set up OpenEBS on an existing Kubernetes cluster. And then we will see how a data scientist tries to launch a ML app, that is a Jupyter app, where the underlying storage is OpenEBS. I'll try to switch some screens in between. Just hold on.
Share the screen.
Yeah. All right. So, okay. Is the screen visible now? I just switched the screen to context. Is it visible to everyone?
Yeah, I can see it now.
Okay, thanks. So what we are seeing here is a Kubernetes cluster, which has 3 minions, and they belong to a particular version, 1.6.4. This is pretty clean cluster. It doesn't have any pods or any deployments apart from the basic Kubernetes services running. This is just a service. And we also shall see some of the storage classes. Okay, so we see the default storage class, that is a GCE PD, the persistent disk. But apart from that, it doesn't have anything else. So what we'll try to do is first try to do what a admin would try to do to have OpenEBS on this Kubernetes cluster. All right, so for the first step, the admin has to install OpenEBS, which in other words is an OpenEBS operator. In order to do that, we need to change the context to use the admin. We'll do that here. Here we are trying to apply the OpenEBS setup, that is install OpenEBS setup on a Kubernetes cluster. One second. All right, so what we see here is a sort of roles getting created, cluster role binding, then a sort of deployment service getting created. We will just go through that one by one. Oh, okay. Just get out of it. Okay. All right. We'll start with the deployments. We here what we see is API service, that is the OpenEBS API service, and the other one is the OpenEBS provisioner. The provisioner is nothing but the volume plugin that is hooked into the Kubernetes cluster, and the Maya API service is the one which exposes some of the REST APIs, some of the APIs which is being used or which is being consumed by the provisioner to create the volumes, the PVs, right? Okay. So the pods are nothing but the same as the deployments. Here, each deployment comes up as a pod. So what we are trying to do now is move back to the context, the default context, before trying out the set of operations that the ML or the data scientist would try to launch the ML app. Okay. All right. So I had forgotten one of these things. We need to also apply, or we need to also install some of the storage classes. When I said we, it's the cluster admin which has to do that. All right. So what we have just see here is a set of storage classes being created. One belongs to the, let's say, the Percona application. The other one, it's suitable for a Jupyter, that is an ML-based application. And the third one is a very basic storage class. We can get that from this command as well. We can see the type belongs to the OpenEBS IO provisioner SCSI. So it's all the SCSI protocol that is being used. And this has come along with the default, the standard one, that is a GCE PD storage class. All right. So before getting into the ML app, that is the Jupyter app, we'd like to see what exactly are the contents or what exactly are the specifications for that app. The app is nothing but a Kubernetes deployment, and it is being run on a default namespace. It's run as a container. And the point that I would like to look here is the volumes, which is mapped to a persistent volume claim. We have got a claim name, and we create the claim here. We can see that the Jupyter data volume fall claim is here. We create it, and here is where we map that claim, the PVC, to a particular storage class that we created earlier, that the admin had created earlier, and that's the OpenEBS Jupyter storage class. Apart from that, we see a couple of storage-specific parameters. And to end it, the ML app, that is a Jupyter notebook, is exposed as a service. with this particular port and with a type node port, so that the minion node, the minion IP, we can use a minion IP and use a node port to browse the app in a given browser. Let's come out of it. All right, so we shall apply the same specs here. Okay, we see a couple of things getting created. One is a deployment, that is the deployment of the Jupyter app. Then we see the service of the Jupyter app getting created. And along with it, we see a persistent volume claim that gets created. So we'll go back and check the deployments. All right, so what we see here is earlier what we had done is, what the cluster admin had done is he had set up the API server as well as the provisioner. Well, once the data scientist comes in and tries to launch the Jupyter app, we can see the Jupyter service being created as a deployment, and along with that, the PVs, the persistent volumes, also getting created because of the mappings that was provided in the specifications, and out of which one is the controller, that is a storage controller, and the other one is a storage replica, which is nothing but a storage disk. And if you come to this side, and if you see the count, it's 2. That means there were 2 replicas that got created. All right, so, and we even can look at the services. Fine. Earlier we had seen that there was only a single service Kubernetes, and once the cluster admin installed the operator, we had the Maya API service getting created. And now after the Jupyter app was created or was launched by the data scientist, we can see the app service as well as the volume service that has got created. Okay. We get back to the pods, and here it's just the same. It's a representation of the deployments that we just saw. That is one storage controller, and there are 2 storage replicas. All are running in their isolated containers. And of course, there is a Jupyter pod that is running as well. Okay. So from now, what the data scientist would like to do is would like to browse the Jupyter app and run some of those ML operations, right? So to do that, what I would do is I would like to get the token in order to browse the Jupyter service. All right, so what we do is, this is the token. I'll be using this token in a short while. Okay, so I shall be changing the context a bit. I'll share my browser in a moment. All right. So now what we are seeing is the Jupyter app running on a browser. This Jupyter app uses OpenEBS as its underlying storage. And before logging in, we have to give the password, that's the token. And I had copied the token earlier. I just feed it and get into the app. Okay, we'll browse through the app. And for the purpose of this demo, we have this particular thing running, Women in Higher Education. This is the Pi notebook. All right, so there are a couple of operations. What I would be interested to demo here is one operation that is very specific to storage. In other words, this will do some IOs. It will run some IOs, and I want to run it for a long time. And let me run it. Okay. So again, I'll be switching back. I'll be stopping my screen a little bit and switch back to the cloud cell. All right, we are back with the shell window. What I will do now is I will get into the Maya API service. I'll get into the container and show some of the commands that will give me some statistics, the storage IO statistics. All right, so I am currently under inside the container that is running Maya API service. What I will do is I will use Maya, the CLI. This is the CLI part of OpenEBS. I'll use the CLI and I will list some VSMs. VSMs are virtual storage machines. This is in short, the VSM represents a controller and the replicas. We just name it as VSM. And we can see this is the VSM which is currently running. I'll try to watch the statistics of the VSM now. Okay, I'll try to sleep every second and VSM stats. All right. Okay, so what we see here are some of the statistics, some of the core storage statistics. We can see some of the read and write statistics. These are the throughputs, and then we can see the latency, and as well as the block size. Okay, so okay. Well, this was all about the demo. Maybe we can start with the question and answer session, if at all anybody's interested with. Hello. Is there any question about this demo on the running of the app, about the operator, anything?
Hey, Nishat, are there any questions in the chat?
Not yet, sir.
All right. Thank you, Amit, for the demonstration of Jupyter application on OpenEBS 0.3. So what we essentially saw was how easy it is to deploy a stateful application on Kubernetes, where the storage is being provided by OpenEBS. So you don't have to go and create the volume and manage it. OpenEBS, by interpreting the configuration of the application, it's going to take care of scheduling and provisioning, and then connecting that volume to the required application. So this is essentially one of the main features that we implemented in 0.3, coming up to the speed on meeting the persistent volume and volume claim architecture. And now with 0.3, you can go ahead and use the OpenEBS storage classes with underlying disks as local files. So this is a fully hyper-converged system, and some of the other updates are we are joining various open source forums to start contributing the technology discussions, as well as to contribute to various standard bodies that are coming up in the storage container areas. So one of them is CNCF, and the effort that we will also be contributing towards is the Container Storage Interface effort, CSI. And then we're slowly participating in various city meetups within India, US, Europe. For example, we are there today and few days this week in DevOps Days in Amsterdam, and we will be participating in various meetups where Kubernetes storage is being discussed. So you will see our participation growing more and more in applicable areas. So glad to see a user contribution increasing on our Slack channels as well as on the GitHub. Those are the project updates that we have for this Hangout, and we'll soon be publishing a 0.4 milestone plan, and probably will think of moving from a quarterly milestone to a shorter milestones in the near future as we get more user base. So if there are any further questions, we will take them, else we will probably conclude this Hangout session. Hey, Nishant, you want to add anything or any other chat questions that are coming up?
Till now, we haven't got any chat questions, so probably we'll wait for another 2 minutes and close that.
All right. All right, guys. Thank you very much for your participation. Looking forward to meeting you in the Slack channel and other forums. Till then, Have a good day, good evening, and good night. Thank you.